Hey, what's up everyone? Welcome to this new live stream. So, like I said on the thumbnail, today we're going to have a look at some of my oldest iOS apps. So, we're gonna take a look at three different projects. They're all available on GitHub, so you have the links in the description if you want to check them out. Two of them are in Objective-C, and one was in Swift 2.0, and I had to convert it to Swift 4.0 because otherwise it wouldn't build with a modern Xcode, and I couldn't run it on an iPhone that runs iOS 16, and I only have that at my disposal. So, how about we get started with the first project? And I'm realizing I've opened the wrong project. That's not the first one. This is called Pong Break, but that's not the first project. Let me open the correct one. The one I want to open is called Geomento. I'm putting the window at the right size. All right. So I guess first thing I'm going to run the app on my iPhone to show you how it works. So I'm going to do a bit of work because I need to tell you that I actually don't have a paid Apple developer account. I only have a free account, which means that I can only install one app on my device. I need to remove the old one and reauthorize my developer profile basically every time. And I am not running on the correct phone. I want to run on that phone. Okay, so the app is installing on the phone, which is a good thing. I just need to authorize it, and then I will share the screen of my phone. Let me go into the settings app. Never remember what it is. Device management, that's it. Okay. I think we are good. So I'm gonna share my phone. So you should see my phone on the live, and I'm going to launch the app. You can see the icon. So I'm going to allow it to use my location. Wait, no, it's not the right app. No, it's not. Definitely. The right app is the one called Visual Reminder. Like, you can see that these apps are a bit old, and I really want to do them chronologically because this way we can see like how the technology evolved. So I'm gonna remove Geomento, which chronologically is the most recent app, even though it's from 2015. And I'm starting Visual Reminder. Okay. So just like before, I need to go into the settings and allow my count. Perfect. Okay, now I can launch the app. So what is this app about? This app, so to share some context, this app was made in the summer of 2013. Actually, yeah, I was thinking 2014, but no, it's 2013, so it's almost 10 years old. And I made this app like when I was doing my first internship that paid a bit well, and that I could invest the 100 euros to have like the Apple membership for a year. Because up until 2014, you had to pay if you wanted to build on a device. You couldn't build like just one app. You had to pay if you wanted to build outside of the simulator. So I paid and I built this little app. So Geomento, if I show you, no, Visual Reminder, if I show you the icon, you can see that there is a Polaroid there. You can see it's also the old styles of icon with the shiny effect on it because I guess I made it, yeah, I made it just before iOS 7 was released. So really an old app. And it was inspired by the movie Memento. So if you don't know the movie Memento, it's an amazing movie by Christopher Nolan that is actually like it starts from the end and goes all the way to the beginning for a reason, which is that the main character had a brain injury and his memory is limited to like 3 or 4 minutes. And after that, it resets to zero for him. And so that movie is from before smartphones, and the main character takes picture of Polaroids of things he wants to remember and takes notes on the Polaroid. And so I took inspiration from it because you can take a picture. So I'm going to take a picture of, I don't know, like So this is the remote of the lighting that's actually lighting me. And I'm going to take the picture. I say, okay, I want to use this photo. And as you can see, we have something kind of inspired by Polaroid. Of course, I'm in dark mode, but this app does not support dark mode well, so I'm going to remove dark mode. You can see that since I haven't changed the code, I guess like it was looking better back then, but with the new addition of iOS over a period of 10 years, definitely like things that are like this gray bar like was not supposed to be there. But the great thing is that I can add a comment under the picture. So for instance, this is the remote of, damn it, my, okay, I think I need to go to an English. Lights. This is the remote of my lights. So it looks like this. Of course, like it's been made back in the days of the iPhone 7, so you can see that it's all like scaled and all of these nice things. We have a table view, so we will take a look at the code afterwards to see like how did this look like in Objective-C. And if I take a picture of another thing, hey Chris, like for instance, I don't know, this is my apple juice. So I use it. Yes, 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 Alex. As you can see, I had added a custom fonts, and I guess we will see how I had handled it in the code. And so here, like this is, okay, the keyboard avoidance is not perfect. This is my apple juice. Okay, just in case I forget, like this is my apple juice, I need to drink it during my live. And there was a swipe to delete, which I guess was like where I stopped with this app. So this app was actually available on the App Store if you were like lucky enough to look for it on the App Store between like I guess August 2013 to August 2014 when I stopped like when I didn't renew my account. You could have downloaded it and used it. I guess the Notes app didn't exist or didn't have like that many features back then because, of course, today this is a duplicate of the features of the Notes app. But what's interesting is that now that we've seen this amazing app, we're gonna take a look at the code. So you know what? I'm just going to mask. Yeah, I'm going to get rid of the app, and let's go take a look at the code. So one of the great thing when you have a project in Objective-C is that I didn't need to change anything for it to build today because Objective-C hasn't evolved a lot, and that was very different for the Swift project. The only thing I had to add is the string in the playlist to explain what you are using the camera for, otherwise it would crash. And we can see that we have a lot of errors in the console, so we'll take a look at them a bit later. First, I want to show you like what did a project created in 2013 look like. So first, it was using Objective-C. So you won't see any Swift file in this project. Instead, you will see what we had in Objective-C, meaning we had a .h file for the header and a .m file with the implementation. Nowadays in Swift they are kind of like all bundled together because in Swift you put everything in a file and then depending on the visibility you've given to your types, your properties, your functions, the compiler is able to generate a header for you. But in Objective-C, the headers and the files are two different things. And one thing you can remember is that there is this two letters, so before the app delegate, like LF app delegate. And the good practice back then was to put this kind of like, how could you call it, like an acronym, I guess, before the name of your class. So just like you had, for instance, NSArray, NSDateFormatter, etc. And the reason was that Objective-C did not have namespaces. In Swift, there are namespaces. Modules are namespaces. So in module A, you can have a type called I don't know, like called user. And in type B, have another type called user, and your app is still going to like build, and you will still be able to disambiguate which user you are referring to. That was not the case in Objective-C. That's why you had to manually prefix every type. And so I guess I had taken the name Little Factory back then as a developer, which like I dropped almost as fast. And you can see LF is for that. we have the date. So I created this project on the 10th of September 2013, not August. I guess like I bought the account in August, but September. So we are in the time between I have finished my internship at Worldline, but the classes for my last year of engineering school haven't yet started because they started at the end of September. And during the empty time, I was like, why don't I spend like 2 days trying to build an app and go through the process and have that experience on my resume. So let's take a look at the app delegate. So we have the old import style statement, because then you had at import, but was before that. So you would declare an interface, which would be a class, and we would give the name of the class, and then the name of the protocols you would implement, or even like, is UI responder a class or a protocol? Okay, it's a subclass of LS object. So actually, my app delegate is a class, which is logical because you want to instantiate it. So it's a subclass of UI responder, and it implements the protocol UI application delegate. This syntax right here with the braces is how you would implement a protocol back in Objective-C. Then we had properties. So properties, we used at property, and then a C-style syntax where you have the name of the type and then the name of the property. I was about to say of the variable, but it's kind of the same thing. You can notice this little star right here, which says that we are dealing with a pointer, and basically, or anything that inherited from NS object was a reference type in Objective-C. The only things that were value types were like ints, cars, bool was also a value type. So only like the base types of the language, and everything else was a pointer because everything else was allocated in the heap. For the people who were doing Objective-C back then, I have a riddle for you. What I've said was wrong when I said all objects were allocated on the heap in Objective-C. There is one exception. There is one object type that can sometime be allocated on the stack. If you know what it is, please say it in the chat. It's a tough question. It's really a tough question. Then what do we have? So we have the window. We have things around core data, because I didn't tell you, but the data was persisted. I had implemented core data, or rather I had created a project in Xcode with the core data app sample, and I hoped I wouldn't break anything when I implemented my own code. But we can see the managed object context, the managed object model, and the persistent score coordinator. So this one, it's your data model. So it what represents, we could say, the schema of your data. This one, I'm not sure what's the difference between the object context and the object coordinator. I think the coordinator manages like writing to the disk, and the context manages like when your instances should be updated or how you retrieve them. I guess we'll be able to see it a bit later, or I could just do an Alt tab. No, Alt tab doesn't work. You can see also these strong non-atomic things. So what are they? So we are in old code, but we are not in very old code, in the sense that maybe you've seen that in Objective-C at some point you needed to handle the memory manually with retain, release, that kind of code. So we are after that. Arc, so automated reference counting, is still here, is implemented in the app. And the way Arc worked is that it used these annotations like strong here to get some semantics on how the properties, on what the properties meant. And from that, it would automatically generate the retain release code. So when this was released with iOS 5, it was really, really a big deal, because retain release was basically a nightmare, and a place where there could be so many bugs and a huge barrier to entry for juniors. So really, like the adoption of Arc was a major relief. And so when you would say your property was strong, the compiler would derive that this is a strong reference. And so whenever you set a new value to it in the setter, it's calling retain on the object. And nowadays in Swift, we don't have to explicitly say strong, because all the references are strong, and we say weak only. Like strong is the default, and we say weak when we don't want to take ownership of the instance. Then we can see here read-only. So read-only meant basically that in the header you would only have a getter and not a setter. You could also customize the name of the getter or the setter, I think. It was kind of useful for Boolean properties because like for the getter, usually you would like to have is and then the name of the property. And finally, we can see non-atomic, which would mean that the property would not be thread safe, meaning that the code generated by the compiler, I think the term Apple used was synthesized by the compiler. The code, so synthesized by the compiler, would not take care of thread synchronization. So you are not to use this property across threads. They are not thread safe. And then we can see the declaration of some methods, so save context and application documents directory. So it's a very different syntax than in Swift because just like with C, the return type is at the beginning, and then we have this minus symbol right here, which means that this is an instance method. For a class method, you would have a plus symbol, and this would be extremely confusing for people that were using UML diagrams, because in UML plus means public, I think, and minus means private, so totally different things, and this used to get people very confused when they were getting started with Objective-C. But this is what the header of your app delegate would look like. And for the .m file, so the implementation file, well, you would import the header of the header of the type. That would be mandatory. And then you would also import types that you would like to use, but only inside the implementation. So here I am importing the header for the main view controller of my app. Then we have this thing at implementation LF app delegate. So this is where we are opening the implementation. So I didn't explicitly say it, but you can see the at interface right here. So the declaration to start implementing the interface of a class is finished with this at end. So we don't have things like curly braces, we don't have things like this. Instead, it's a mechanism where you have like one keyword to start and another keyword to end. So it feels a bit weird when you've done some Swift, but back then it felt very natural because after all, this was the only thing that we had at our disposal. And so inside the .m file, we have this thing called add synthesize, so where we would tell the compiler to synthesize the property. And I think back then it would do it automatically already. However, by doing this equal thing, we can say that we want to have a property, a variable, an instance variable that we can access so that we don't go through the setter. And this can be helpful like when you want to bypass the setter in some places. So I guess it's going to be used later. Then we have implementation of some methods. So for instance, application did finish launching with option. So this is what it looked like originally. And actually, since the method is at Objective-C in Swift, this is what the method is being translated to. So when you see a selector being mentioned in Swift, it means this. This is what Objective-C called a selector, because it would then say to the instance, do you recognize this selector that was transformed to a string? And the answer would say, yes, I recognize it, or no, I don't. And in this case, you had a crash. And here we can see one of the key features of Objective-C when compared to other languages back then was the fact that you could have the external arguments names that we have in Swift also, but you could say application, okay, the first argument is application, then did finish launching with option, and the second argument is the launch of options. And that's what allowed this very readable call site. And it was one of the very features that made Objective-C different from other languages. Then we open a scope, so this time with curly braces. One of the reasons also why we use curly braces here, but not for classes, is because I think Objective-C was seen. I think Objective-C is what is called a strict superset of C, meaning that every valid C program is a valid Objective-C program. That's not the case, for instance, of C++, because C++ defines keywords that are valid identifiers in C. Like, for instance, I don't know, new, for instance. In C, you can have a variable called new. In C++, you can't because it's a reserved keyword by the language. However, that's not the case of Objective-C, and that's why you have these at things, is because since at something is not a valid identifier in C, using this for the keywords specific to Objective-C made it backwards compatible with C. So that's the reason why that's the reason why there is these two kind of like different syntaxes that feels that they are cohabiting. It's because arguably Objective-C is really like a syntax built upon C, and when you run it, actually you can. I've been told it's not that hard to build an Objective-C like compiler, because you're not actually like we're not talking about like compiling this code, but just compiling the method dispatch and this kind of thing. And I've been told that there are some like engineering schools that do this as a like a first or second year project. So I guess it's quite doable, because it's mostly about like managing like the types and managing the fact that you translate the selectors into strings and dispatch them correctly. Okay, what do we have then? So inside the application did finish launching with option, I would create a navigation controller. So no, I would get the root view controller and say it's a navigation controller because it's set in my storyboard. Then I would take the top view controller and cast it as an LF reminder list view controller. So this syntax, it's a cast in C and Objective-C, and it's the equivalent of an as exclamation mark in Swift. And then I would set two properties on the controller. So I would set the manage object context and the fetch request that is used to get all the objects to display in the list. So this is how we got like all the pictures with the text. And then this is mostly like a boilerplate. When we exit the app, we save the context, we persist data to the disk. So the way it does it, it takes the managed context, and if it's not nil, if it has changes, then it calls save. If there is an error, it logs it. So this is code that was, I think, generated by the template in Xcode. And then we have the code so to create the managed context. So what we do is that if it already exists, we just return it, and otherwise we instantiate, we get the persistent store. So this is also like, yes, this is how you call a method in Objective-C. You would do like the name of the variable, a space, the name of the method, the potential arguments, and then like braces before and after. And this is what people used to find like super weird, especially because when you wanted to do a new, you would do like alloc init. So alloc is called on the type, and it creates the place in memory to store the instance, and then init initializes that space in memory. And this alloc init is the thing that would always like weird people that would only like that only knew like Java or C++. It would always like weird them out because it looked so different. And so yeah, you create a store you get the store coordinator, you create the manage object context, and you give it the store coordinator. So let's see. NS persistent clause. Ah, I cannot get the doc. That sucks. And if I do a command click, no, there is no like docs about what it does. Okay. Let's keep moving. And for the persistent store coordinator, we create it. We basically like so core data uses an SQLite database to store the data. So we give it the name of the SQLite database, and we create the store coordinator using the manage model. Okay. So here it said replace this to handle the error appropriately. You can see that I did not do it because it was an app on which I spent like 2 days like tops. And this is the application documents directory, so where the documents are being stored inside the sandbox of the app. Okay, that was our first Objective-C file, and definitely a different flavor than what we have in Swift these days. Then let's take a look at what we have in the storyboard. So I did everything in the storyboard. It was when storyboards were super popular. I think Apple started pushing storyboards with iOS 15. I was about to say iOS 15, no, iOS 5. iOS 5, I think they were introduced with iOS 5. Before that, there were only xibs. And so you can see I have just a navigation controller, which is the entry point, and inside a table view. That doesn't cover like the safe area, but of course back then safe area was still something that would only happen like years later. So what can we see? We can see also the data model. That's super interesting. So the data model, I have two entities. I have the reminder, so it's basically like the Polaroid you see in the app. So if I display the app again, it's the whole object that you can see. Like, can I point to it? Yes, this object, like right here. And so in terms of what were the wanted to hide this. What were the fields? So we had the date, because I don't think I display it, but it's always a good practice to store like a date in case you want to do some ordering. A notion of done, so maybe you could like click on it to mark it as done. Did I implement this? Maybe I just like I was looking ahead because I try to double tap or do things like this. Don't think there is a notion of done in this project. Maybe I was like, yes, this will be useful later, and I never used it. So done is a boolean. Then we have image, which is called a transformable. And if I remember, transformable, it means like anything that can be like stored, encoded and decoded to binary data, and UI image conforms to transformable. And that was like a great thing because I was able to persist images very easily. I don't think I struggled at all for it, so that was great. And then there was a long comment and a short comment. So we've seen the short comment. This is like this thing right here. And I guess I had really thought like, yes, I'm going to do a detailed view with a long comment, but it seems I never got around to do it. But in the third project, I've done it. So you will be able to see it. There were no relationships here and no fetch properties. However, here we had so the reminder list. So I guess at some point I was thinking maybe we could have more than one list. And so the list would have a name and there would be the reminder. So it's a relationship towards the type reminder. So a one-to-many relationship that will manage the list. And finally, we have the fetch request. And so it's what the view controller uses to fetch data from the data store. And here it's going to fetch all reminder lists objects where true equal true, basically, because there are no conditions. So it would fetch all of the objects and display them on the screen. So actually, this is what's being used to display this image right here. And then the configuration, I'm not sure what this is about, or maybe you can like say the class is abstract. Okay. Then we can take a look at the model. So I think this was generated by Core Data. Yes, this was like generated. And so basically, like you have all of the, I'm going to hide the phone. You have all the things you would expect from a framework that deals with data. So basically on a reminder list, so it's the object. We say that it inherits from NS managed object. So anything that is used that comes from Core Data is a managed object. This is why you have all the logic like to deal with the persistency and whether the object was modified and that kind of things. What's interesting? Oh, we have add class reminder. So that's interesting. That's what you use when you want to say that something is a class, but without importing the header file. So you're just telling the compiler, like, I swear that by the time you call the linker, there will be a class called reminder. I don't remember, like, you don't provide one if you get a crash or if you get a compilation error. But I think you get a compilation error with a very, 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 very cryptic error message. And I guess this was also generated by Core Data. And you see like you have methods to insert so a reminder in the list at some index. Basically that's all the methods to deal with this ordered set properties which implement the relationship one-to-many between the reminder list and the reminder. And inside the implementation file there is almost nothing. There is only the properties being implemented with add dynamic. And what add dynamic says, it says to the compiler that the implementation will be provided at runtime. That's one of the great features of Objective-C, which is still usable in Swift for all the methods that use the Objective-C dispatch. Maybe you've heard of something called Swizzling, which allows you to hot swap at runtime the implementation of a method for another implementation, which is kind of crazy. And there are a lot of third-party SDKs that do a lot of weird things using that. Like if, for instance, you ever see like an analytics SDK that can like automatically like send like events when a view controller is displayed, this is what they used. Basically, they swizzle a view will appear for their own implementation. And so add dynamic meant that at runtime, Core Data would be able to generate the implementation of the properties and feed them, send them to the runtime and tell the runtime, all right, when someone is calling the getter or the setter of the property name on an instance of type reminder list, you dispatch the call to that method. And so you didn't have to commit any code. It could be generated at runtime, one of the very powerful features of Objective-C. I didn't thought of mentioning it, but of course, if you have any question, remark, whatever, please say it in the chat. It's here for that. I will try to answer as best as I can, and it will all depend on my abilities to remember Objective-C. But I worked quite a bit in Objective-C because I started iOS in 2011. And so like I did an internship in 2011 Objective-C, 2012 Objective-C, 2013 still Objective-C, and 2015 when I worked at Group Seb, it was still Objective-C, and it was only getting started with Swift, and it's only when I joined Worldline that I started to do like Swift all day in 2016. So I still did like 5 years of Objective-C. So that's why I have pretty good like memories of it. And then we have the other entity, so the reminder, which is more simple, arguably, because there is no like relationship to manage. And so we have the properties. So an NS number, which is like a class wrapper that could store either like an int, a double, a float, or even a boolean for that matter. NS string, NS date, and this thing here called ID. And ID is kind of the equivalent of any object in Swift. So I'm saying ID. But in the official Objective-C programming book, they tell you that it's supposed to be said id because it comes from Latin id, which means this. And so it's a way to refer to something about which we don't know anything. Of course, everyone says ID, but I remember that in the docs it says, no, this is Latin, you should say id, which no one does. And you can see, so they are non-atomic. There is the retain. Retain, I guess it's kind of equivalent to like strong, a little bit, maybe it's a little bit less smart, but since this is like generated code, there must be a reason why it's retain and not strong, but I'm not knowledgeable enough in Objective-C arcanes to be able to explain what's the difference. One super weird thing, oh yes, in Objective-C, you can notice that there is no star when you use ID, and it's because like ID, it's kind of like void star, but not really, but kind of like it. And so the star is included inside of it. And a typical beginner's mistake would be to do this, which is a pointer on a pointer, and is a mistake. And that was like one of the typical like errors that you could have in Objective-C. There were a few pitfalls in Objective-C, definitely. And so for the implementation file, just like before, it's empty because everything is provided at runtime. So that was the model, the core data model. Now let's take a look at a simple view, like the cell that is displayed, that is used to display like the picture with this nice like Polaroid effects. And I remember when I was making this Polaroid effect, I was wondering like, am I allowed to do it? Like, could I get sued by Polaroid for it? And back then, like Polaroid was actually like, first my app was downloaded by like 100 people max, and it was a free app, so nobody cared. And also back then, Polaroid was a dead company. Actually, like the company went bankrupt, and now the brand has been bought back and is being used again commercially. But back then, Polaroid was like completely dead. So I guess it was kind of okay to use it, even though I'm not a lawyer and I have no idea like whether I was allowed to do it or not. So let's take a look at the cell. So we have a xib. A xib is what you use to define interfaces in iOS, and before that in macOS. By the way, I'm planning to make a live stream in the future where we're going to build an app using the Xcode that was in Leopard in macOS 10.5, so the version from 2007, I think. I'm just waiting to get like the cable to plug the output, the video output of my iMac G4 to my MacBook Pro to be able to stream it. But there will be this fun life of building a simple app using the old Xcode and see if we can manage to make it. But we will be able, because I'm saying this because here with Xcode, everything is embedded. But back then, the software to use to design these xib files was called Interface Builder, and it was a separate software that was still installed with Xcode, but it was a separate software with its own icon, and you needed to like launch it separately. So you will see it. You will see it soon. So we have xib, and arguably, this is the part that hasn't changed a lot since then, because if you were to create a UIKit app in Xcode today and to use xib for your table view cell, arguably you would get something that is actually kind of similar to this. And so I have my cell, so it's a subclass of UI table view cell. Where can I see this? I can see it here. So table view cell. It's a custom style. So I gave it a reused identifier. I have give it some information. I have this UI view right here. So this is what shows the image, and it's a good old like UI view. I'm looking like, are there constraints? No, there is no constraint. There is an auto resize mask. I'm thinking, were there already constraints back then? Yes, there were constraints because the iPhone 5 had already been released and constraints were introduced in iOS with the iPhone 5. But I didn't use them because I guess since the cell would always have like a fixed size, I didn't needed them. So this is the auto resize mask. If you've ever wondered like what does the property translates auto resize mask into constraint means, this is the auto resize mask, and this is what you would use before constraints to say like how a component, how a view should react whenever its super view size would change. And it was used mostly to deal with going from portrait to landscape orientation. So I have this image view, and I have the Polaroid view, which is behind, and there is the short command field. Let's take a look at the custom font. So this is where I've set the custom font that you were mentioning, Alex. So Noteworthy bold, and it was one of the fonts that were added. Yes, I remember we have added it. Oh yes, I remember. So it was a system font, I think. Yeah, it was a system font. I didn't need to like include a custom font or anything else. However, the fact that we could use a custom font and attributed text inside a UI label or UI text field was something quite new. It was introduced with iOS 6, if I remember it correctly, and before that it wasn't available. And in my first internship, it was in at Aquafadas, which has now become Rakuten DX. They were doing like digital publishing in 2011, so it was on iOS 3 or 4, I think, iOS 4 actually. And back then, if you wanted to do attributed text, you had two choices. Either you used a web view, a UI web view, and then you use CSS to style your text, which was arguably like a pretty good choice because the alternative was to use Cortex version 1, which was a C++ library to deal with text. I had to deal with it a tiny bit, and I'm still traumatized by it. So, like, to say that attributed text on iPhones at the beginning was not something to be underestimated. And when iOS 6 added support for attributed strings directly in the UI widget, so in UI label, UI text field, etc., it was really a big thing, and that's why I wanted to try it back then. And then we have the Polaroid view, and I think for the shadow, I might have used. Where did I put the shadow? No, not even here. So I think I've put the shadow in the code. But this is where we have the Polaroid view. But since it's white on white, we cannot see it. But let me see if I change real quick, like the background color. Where can I do it? Here. You can see that it's right there. Let me put it like it was. So this is the cell, and for the actual type that implements the cell, so just like before, we have header .h and implementation.m. So header, we say that there is the protocol LF reminder cell delegate, and then we have our cell. So it's a UIW cell. It also implements UI text field delegate, and it owns a reminder. So the object is going to display. It also owns something that confirms to LF reminder cell delegate. So the protocol to, I guess, say when something has changed inside the text field, I guess, or when something was deleted. And you can see that to say I'm referring to an object that implements a protocol, we say ID, and then between these two things, how are they called in English? Angle braces, I think. I think it's angle braces. Between the angle braces, we have the name of the protocol. Once again, we use ID, and there is no star because of it. And then we have the outlets, so the view, the image view, and the text field. We have a method setup cell, and we have the protocol, so delegate that is here, and that protocol, so it says cell command will begin editing and did end editing. So as I was thinking, it's to I think it's for the keyboard. Yes, it's a way for the controller to deal with the keyboard, I guess. to deal not properly with the keyboard, but that's another topic. And so inside the .m, oh, we have a warning because I am not calling super, so I will fix this bug. But let's see. So first we have the init. So there were, just like with Swift, the initializer were not called constructors, they were called initializers, and they had this weird syntax, especially weird when you came from Java, where like the constructor was just like, okay, like setting some properties. Here you do. This is how you implement the init of a subclass. First, you call the init of the superclass. So here, with Lucky Us, is the same signature. So we just pass along the arguments. And then you can see that we set the result to self. This looks super weird when you think about it, and there is a reason for that. It's because most of the time, it's just going to set the fields like we're doing here and return self. But your super initializer is actually allowed to return a completely different class as long as it implements the same interface, as long as it responds to the same selectors. And a kind of a class that does that in Objective-C, I think, is NSString. NSString, it's called a class, but actually it's more of a protocol, because when you manipulate an NSString, when you handle an NSString, most of the time you're getting a different concrete class that is suited to what you're doing. Like, like, is it a really big string? Is it a short string? Is something static or not? So like there was really like this level of dynamism in Objective-C. That's also why some like programmers that dealt a lot with Objective-C were kind of sad when they saw how much more static Swift was. They felt it was more shackles than anything. You got a lot of flexibility with Objective-C. Arguably, you're getting a lot of it back in SwiftUI, because SwiftUI, when you have the environment and this kind of thing where you can like magically pass some things around the view hierarchy, you get a bit of it back, but it was much more dynamic in Objective-C. So here in Awake from nib, I haven't implemented the call to super, so let's do it. Let's implement an Objective-C call. So on super, I will call awake from nib, and then I will do the braces to mark that this is a call. This is a method call. Or as Objective-C would put it, I am sending the selector awake from nib to the super instance. And the reason why it's not a real like method call is because the Objective-C runtime does this intermediate job of, from the selector, finding out what is the actual implementation. And there might not always be a one-to-one relationship. Most of the time, you want it to be one because you want your code to be like reliable. But you could write some piece of code that would like I don't know, like have like 3 different implementation possible with the same signature and choose one at random. This is possible with the Objective-C runtime. I don't recommend you do it, but that's possible. And that's why Objective-C says that this is like sending a message to an instance and not directly calling a method on that instance. And then we call setup cell. And what setup cell does is that it's going to query the fields of the object, and it's going to set, so the image and the text. It's going to set a placeholder for the text. So it's a localized string. I had made the effort of localizing my strings, and you can see that this is a different color because this is a C macro actually. So a C macro is just like, you can see it as an inline method call, because it's just like the compiler is just doing like, it's just like replacing the code. It's taking like this signature and it replaces it with that. So it's kind of like a search and replace with arguments, basically. Once again, another riddle for you. When I say it's not like a function call, it's because there is one thing you cannot do with a macro that you can do with a function call. If you can guess what it is, you can say it in the chat. So one of the things with a macro is that you can avoid to provide an argument. So like here, you can see that I'm not providing a second argument. It's not the thing I had in mind. There is another thing that is not possible with a macro, but that is possible with a function. Then we set the delegate. We set the cell as the delegate of the text field. And finally, we create this like Polaroid effect by on the layer creating a shadow color and giving it an offset and an opacity. So this is what generated the shadow that we saw. Okay, then this method was empty, so I could have removed it. And then implementation of when we get focus and when we lose focus. Okay, and we update Also, we update the core data object when we are done with the editing. Okay, let's take a look at the controller because time is advancing and I would like to spend like not more than 45 minutes on each project. So this is a UI view controller. You can see it implements a lot of protocols: UI navigation controller delegate, UI image picker controller delegate, my delegate of the cell, UI table view data source, UI table view delegate. So woo, we didn't have like I don't think we had extensions to like break down the conformances. So you would get like this kind of like big files, even though I most probably should have done, like something like that would have been arguably better. But remember, like I was young, I didn't know any better when I implemented it. Does this build actually? Yes, this builds. I'm going to put it like it was just in case I've broken something. So then the controller, so as we saw in the app delegate, it owns like things to be able to interact with the core data stack, and it owns also the reminder list. And inside of it, so what do we do? You can see I defined some constants with the weird like Swift like C syntax. So you would use like this like all caps identifiers, and so this is the reuse identifier and the size of the image. So it's like a VGA like resolution, and this is um, how you would create a struct. This is a literal struct syntax in C. Okay, we have an interface. So the interface, it's a way to add a property. Like it's a way to add a property that is private. This is how you add a private property. You declare an interface, a second interface for your type inside the implementation file. So this was a bit of a brain fuck, especially because in that case, you have like curly braces. You see, like for the regular interface, there are no curly braces and there is an at end. But for this one, which is what Objective-C called a category, I think, you would have curly braces. So like super weird and so easy to get it wrong. And of course, you got a weird error message if you got it wrong, because otherwise it wouldn't be funny. And then, so we have the implementation. So we synthesize the setters and getters and the instant variables for our properties. And so in view load, we give a title to the view controller. We register the nib with the table view for the reuse identifier. We set a background color. We fetch so the list of items to display, and we refresh the data. Okay, view will appear. We register to identify when the keyboard appears. And what do we do in the private methods? So to fetch the reminder list, so the list of data we display, so we call the manage object context. We execute the fetch request list. So remember, it's what we saw like right here, which is like a kind of a named request. It's a named request over like over our core data model. That's exactly what it is. And if there are more than if there are elements, so I should have done some kind of an isEmpty. Did we have like isEmpty? No, we didn't have isEmpty back then. So that's why I didn't use it. So what we do is that if there are elements, okay, yes, because the fetch request returns fetch reminder lists, but we only have one list, but we need to get like the list that is in the array of results. That's why we get basically like we get an array of lists of reminder lists basically. And so we get the one at index 0, because I think there was first object. I could have used that one. And also, yes, back then you would do like object at index 0. Like they added a syntax afterwards to be able to do like something like this. So like that. They added that syntax, but I think it was in iOS 6. It was still, yeah, because it builds, but by force of habit, I didn't use it. But before iOS 6, you had to do like object at index or value for key, and this is what gave Objective-C like its reputation of being like a very like verbose language. And so if there was a list in the database, we just use it, and otherwise we create one from scratch. And so this is how you create a managed object from scratch. Okay. And refresh data, what we do is that we sort them. So we use this thing sorted array using comparator. We use a block, which is the equivalent of a closure in in Objective-C. By the way, when I said at the beginning, there was one kind of object in Objective-C that would be stored on the stack, even though it was an object, and it's inline blocks. If I remember it correctly, inline blocks, they are of the type NSBlock. However, when they are defined inline, they are being allocated on the stack. And so if you want to store them, like if you wanted to store this outside, to be able to use it outside of the method refresh data, you would need to do a copy of the block. Otherwise, you would get a very weird crash. And it's one of the most weird behavior of Objective-C. But basically, this is just like the method like sort by that we have nowadays in Swift. So you get two objects, they are ID, so you need to cast them as a reminder because it's not type safe. So you can imagine for refactoring, like this is, you cannot rely on the compiler to help you. And then we compare the two dates. That's why I added the date to be able to give an ordering. And then we reload the table view. Okay. So we have this, which is just like a way to get like a reminder object without using the array. Then we register for the keyboard notifications. So keyboard will show, keyboard will hide. And when the keyboard was shown, what we do is that we use the content inset to be able to kind of like make the cell visible. So it kind of worked, actually. It kind of worked, but I guess the fact that now we have the safe area, it kind of screwed it. But look, like if I take the focus, you see like it scrolled up a bit. So it kind of worked. Back then, I had gotten the code to work. But of course, now with the safe area that is not supported, it doesn't work anymore because I had hard-coded like a few things right here. Or at least I was not taking into account everything, because what I do is that, yeah, I take the height of the keyboard minus the height of the toolbar, but I don't take into account the height of the status bar, I guess, or something like that. Okay, so yeah, I'm pretty proud of what I had done. And so when the keyboard is hidden, then we scroll back. All right. Okay. And so add button click. So this is when I press the add button right here. So when this button is pressed, we create a UI image picker controller. So this is what we had before the PH picker that we use nowadays. And that's why also like why it looks kind of old when you use it, because nowadays like you would have something a bit more modern. All right, and once the image, like once the picker is done picking the media, so you have a dictionary with what was picked, so you get the captured image by querying the key UI image picker controller original image. Then I create my reminder, I set the image, I resize it to my size. I had created a method, a static method to be able to resize an image to a size. Okay, yeah, I had spent time to make it like to make it work like correctly. Okay. And then I would like add the reminder to the object, dismiss the capture, the picker, and refresh the data on the table view. All right, and yeah, if we cancel, we just dismiss it. Okay, and we had the notion of an active cell. I don't know why we are using this. And finally, the table view data source. So number of sections, number of rows in sections. So one, and the count of the object we are displaying. And then classical stuff like we dequeue a reusable cell. We configure it by giving it the reminder. We call setup cell, and we set ourselves as the delegate. Okay, and this one for the swipe to delete. So table view commit editing style. It's so weird that the name does not reflect at all the fact that you are deleting, and I think a lot of people searched like on Google like how to swipe to delete, and were surprised by the fact that to have this, you just need to implement this method that has like kind of a misleading name. All right, we have an about view controller. I implemented an about. Wow. I had put a PayPal, a link on PayPal if people wanted to like give me money for my app, which was, I mean, it was nice, but I don't think it was worth of money, and no one ever gave me money. But I think I had tried to get money that way. And I was opening Safari because yeah, there was this kind of loophole that if you want to open a PayPal donation page in Safari, you would be able to get money. So like, I know it's not like a contact field, but how do you get to display this like about screen in the app because it's not accessible like anywhere? Can I get it from the storyboard like somewhere? Yeah, in the toolbar there is only the add button. So and here like even in the no, there is no button about. So I guess there was no way to like reach this, even though I had used like Mail Composer to compose an email to send me an email or to share to Twitter also. Donate button, of course. I had fun. Okay, the utils, we saw it. Oh yes, back then the iTunes artwork that you need to provide like an image with no extension to be used by iTunes as the image. The playlist, we saw it. Okay, the main file, nothing fancy here. And the localizable, okay. The tests, were there any tests? No, there were no tests, of course. Only the standard generated testing targets. Okay, we've seen this, so it's almost my oldest side project. My very oldest side project, it was 1 month before, but unfortunately I have completely lost the code. It wasn't on my GitHub. It was an app that would display like an ebook. I had gotten like found a way to get a JSON with the text of a French book called Les Fables de La Fontaine. And I had made an app that showed like this like book with some nice ebook feature. But unfortunately, I don't have the code of that one, so I can show it. I can show it. So we've been using Visual Reminder, so an app I made in September 2013. Now we are moving 1 year later. No, 2 years later, I think. I think 2 years later. You know what? Let me like close the project. Okay. So not this one, the one called Pong Break. So let's see the app delegate. When was it like created? Okay, July 2015. So July 2015. So when I graduated, I worked on like web development for a year, and then I was like, okay, I would like to get back into iOS. And like one day after getting out of work, I saw that there was like a discount at a electronic store like next to where I worked. I mean nearby, and I could get an iPhone 5C for like 300 or 400 euros. I think it was 300 or 350. And I was like, hey, I had an Android phone back then, so maybe I should buy it. And since you could like develop with a free account, I could like get back to iOS. So I think it was a good choice that I did because this is what led me to here right now, basically. But I bought this like white iPhone 5C, and the first thing I developed for it was a video game. So you're about to see like the only extent of my game designer and game developer career using SpriteKit. And I developed this like basically like over a weekend because I wanted to have a side project to kind of like convince my old company that I could try to do some iOS stuff. So I'm going to build the code so that we can run it on my iPhone. So it's called Pong Break. As the name suggests, it has something to do with Pong and something with like the game where you need to like break everything. I don't know the name of it in English. In French, it's Casse-Brique, but in English, I don't know the name of it. Um, Once again, I am building on the wrong device. I'm building on the iPhone that's actually filming me. So I'm super scared that my mistake are going to cut my camera feed. It seems it wasn't the case, and I'm lucky. But I had to like restart both my computer and my iPhone to make the continuity camera work. So I'm super scared about it like stopping mid live. Okay, so I need to like. Okay. So I see a question: is it better to build a monolithic or a modular app? So first thing I want to get across: this project I'm showing are by no way an example that you should like follow. Really, like by no way they are an example. They are just like old projects I did. So please don't take example on this. And I guess when you get started, you always start with a monolithic app, but then you should try to like modularize things. Of course, that's a better strategy. But to be honest, it's a very like I don't know, like it's not a precise answer, but it's hard to answer it without going like into too much details about it. What I can tell you is that on my channel, I have a previous live stream about architecture, how to architect an iOS app, and you might want to take a look at it afterwards. Maybe it could help you. Okay, let me display my phone again. Let me launch this amazing Pong Break app. Um, you can notice the fact that I have designed the icon app myself using Photoshop back then, and I was pretty proud of the fact that I've been able to add this. You can see like this, how do you say, like a speed motion blur effect to the ball. I was very proud of it. But let me show you what this is about. So it's a game. I didn't touch the code, so like it displays outside of the screen. I swear it wasn't the case when I implemented it. Maybe we'll try to fix it as we go over the code. But it was a game where you would play like Pong. So there's this idea of like like a ball that how do you say it in English? A bowl, yeah. A bowl is what you eat, and a bowl. What's I, I'm realizing that I don't know the difference between how you pronunciate bowl and bowl. Bowl. Okay, it's a ball. It's a ball. Basketball, not basketball. Basketball. So there is a ball that is going to like hit portions of the circle. Once a portion has been hit, it disappears, and the ball will also rebound on the portion. And the goal is to rotate the circle. So we, as the player, we control the circle and we rotate it. And the goal is to destroy all of the portions of the circle. And as you're going to see, this is extremely hard because as the circle like gains motion, basically, if your circle gains momentum toward the left and you want it to go toward the right, you will need to swipe to create some friction in order to cancel all of the kinetic energy to be able to switch direction. So this is the simplest way to implement it, not the most like fun way like gameplay wise, but this is what I went with. And so like try again. We can try. We're almost there. Let's see. Oh, damn it. I'm trying one last time, and then I will show you the trick to be able to win almost always. So like that. I think there were also like I had implemented. Yes, I got it. I think I had implemented some like some sound effects. I'm going to unmute. I don't know. Maybe I don't know if you hear sound effects, but I had implemented some sound effects back then. Okay, so I've lost. And let's see. I just want to see if you could like hear the sound effects. No, I guess they don't work. That's too bad. Okay. And so if you want to win, you just like build up a lot of energy and it goes so fast that the probability that you will actually hit something become like quite high. But in the end, it's not guaranteed. Okay, so this is completely shitty as fun wise because this is going to like drain all the energy out of your body, all of the happiness out of your body if you try to play this game. But let's see how I implemented it using SpriteKit. And I remember like I was pretty proud because I had done it like basically like over a weekend. I think. I remember, yeah, I bought the iPhone 5C like Thursday end of work, and I was like, this weekend I'm going to like use it because this way I will prove myself that I haven't thrown money out of the window, and I implemented this. So we are on the 11th of July 2015. I am still not a professional iOS developer back then because I had done only internships, and I was working as a professional web developer. So this is before I was a professional iOS developer. I could call myself that as someone who gets paid to do iOS. So we won't go over the app delegate because we've seen it and it's boring. The main storyboard is empty basically. We just have a view inside of it. But since we do SceneKit, everything is managed outside of the storyboard. So we have things called like, okay, we have these things. Let's see, where should we start? Let's see what is this PB shared instance. So PB stands for Pong Break. So the shared instance, there is absolutely nothing in it. I don't know why I created that. Maybe I use a template in Xcode to create a sprite kit like project, and they put this so that you can put like your code inside of it. But this is a shared instance implemented in Objective-C. All right. The game manager. Okay, this is more useful. So another shared instance. Oh, it's a subclass. It's a subclass of the other. Yeah. Back then there was this idea that sometimes you should like put like abstract your code into a superclass. So I guess I wanted to abstract this code right here to create like the shared instance and create it only once. And I created a superclass for this. Needless to say, like superclass are much less fashionable these days for iOS apps. All right. So in this game manager, so this is what keeps track of the state of the game. We have the current level, the current score, and the best score. There was a notion of best score. And then we have a method called when a border is destroyed, when a level is completed, or when we fail a current level. Okay. And what's happening right here? So the first level is level 1, so we have some constants. The user defaults key to store the best score, so actually it was persisted. I did things like correctly. Okay, so in the init, the current level is the first level, and we get the best score from the user default, all right? Setting the best score just sets it in the user default and also in the underlying instance variable. So when a border is destroyed, we increment the score by the amount of the current level. So the idea I had for this score is that basically when you destroy a border in level 1, it's worth 1 point for each border. Then in level 2, it's worth 2 points per border, etc. So this way, like the score grows, kind of like the number of borders grows, and the number of the scores. So I guess it maybe it doesn't grow like exponentially, but at least like it grows pretty fast. And the idea is that as you progress into the game, the much higher your score will get. But since the game is so hard, you will never progress in the game. So actually, that was a bit of like getting ahead of the user's need. Okay. When we have completed the current level, we increment the current level with the plus plus syntax, which is one of the poster child, one of the how do you call it? Like I forgot the name for it. There is a word I forgot, but one of the typical like syntaxes of C languages. You do this plus plus instead of current level plus equal 1. Fun fact, but this syntax was there in Swift at the beginning, and then they removed it because they were like, yeah, this is a little bit too far away from what we want to implement in the Swift language. Okay, and when we have failed the current level, so if the current score is greater than the best score, we update the best score with the current score. We set the current score back to 0 and the current level to the first level. So this is really like the thing that manages the logic of the game, but not the logic of like the ball breaking the borders, but more like the gameplay, the game board logic, we could say. Okay, then we have so the game scene. So the scene is yes. So that's the thing in Sprite that you can use. And I didn't use this. I just created a scene because you have to create one. But I guess if you want to have like a level where you like really like you put sprites and then they can like get animated and things like this, you use the scene. Me, I didn't use it. I did everything in the implementation file. So I have the game scene, which is the thing you see like is this thing that is the view that you see being displayed on the screen. So what do we have? We have a gesture recognizer to recognize when I am swiping over the screen. We have what SpriteKit calls a node. So a node in SpriteKit is kind of like a view in UIKit. It's something that is displayed on the screen and that you can interact with in the game potentially. So a label is just like a UI text view. So ready is what's being displayed at the beginning. So I guess it's the touch the screen to start thing. The score is what we have at the center of the screen. Then an action, so to break the sound when you break something and when you like complete a level. So why didn't we have like it's weird we didn't have Maybe because I'm in like do not disturb. Maybe that was why we don't have the sound. But I had added like the sound. You know what? I'm just going to like remove do not disturb. Going to put it back. Okay. Okay. Let's see. No, still not there. Okay. I guess we will never get the sound. Sorry about that. But you can see I wasn't lying. I really did implement it. Then we have the node, which is going to be like the ball that will be like displayed, and the border nodes, so the segments of the circle. Okay, then we have some data for the physics, so the current speed and the current angle. And this is what we need to store to be able to like propagate, not propagate, but derive the state of the game, the state of the view for the next frame, basically. And then has the game started? And when I told you just a bit before that you could like specify a different name for the getter. So the variable is called game started. You want the setter to be set game started, but you don't want the getter to be just game started. You want it to be is game started because it was a convention, and this way it conveys the fact that it is a boolean, and so you could provide a custom getter name that the compiler would take into account when it would be generating the getter. Okay. Oh, this is interesting. So in Swift, we are very fortunate because we have the lazy keyword, but we didn't have this in Objective-C, and so you had to implement a lazy property manually and say, all right, when you query my property, if the underlying variable is nil, I allocate the array and I set it. Otherwise, I just return the value stored in the underlying variable. And if you take a look at the Swift presentation session by Craig Federighi at WWDC 2014, so when Swift was introduced, you will see that he shows the fact that lazy is implemented by default in Swift. Also, you can notice we are in 2015. Swift has been released for a year, but I'm not using Swift because, like I said, I'm just getting started. I'm just getting back to iOS development, and I'm trying like Sprite is already a big new thing. So doing Swift at the same time would be like a bit too much. But the next project will be in Swift, I swear. And I guess it's my first project in Swift, also that we will see after. Okay. So in SKScene, so we implement did move to view, which is kind of like a view will appear, I guess, kind of like that. So we create the gesture recognizer, we add it to the view, we set up the game scene, and we set up the game level given the current level. Okay. So this is to deal with when touch begins. So when we touch the screen, we start the game if it wasn't already started. Update the time. So this is apparently something that is called a method is called for each frame that is rendered, and you get the current time. And so what I do is that I compute an affine transform that is a rotation given the current angle of the border. So this is what I change when I swipe my finger. And what I do is that for all of the objects in the border nodes, I do a for each. So the for each in Objective-C is this enumerate object using block with this awfully intimidating syntax. I could also have done for I don't remember how you do a for loop in in Objective-C, but I don't know if I do like for border node in self dot border nodes, something like that. Does this work or not? Oh, I guess I need to like do something like okay, this is what it's like. Does this work? No. I know you can do like I know that you can do like a for each loop like this in Objective-C, but I've forgotten how to do it, so I will not do it. But this is the equivalent of for each, and you get the object in an untyped way. You get the index, which is interesting because nowadays in Swift you can get it, but you need to call like enumerate before. Here you would always get it, and you get a stop argument, which is a pointer to a boolean that you can set to true if you want to stop the enumeration, like if you've already like found the object that you were looking for, I guess. So it's a bit weird, but this is how it works to do a for each in Objective-C. So basically you cast the object in the type that you want. So here it's PB border node, so what represents the portion of the circle. And then for its path, we update it by taking its path and applying the transform. So this is how we apply the angle to rotate the circle, and we update the physics body, which is what we'll see afterwards, and that's what's used to detect a collision between the ball and a segment of the border. Okay? So did begin contact. This is where we get into like the 2D game stuff, because so it's all about collisions. Collisions is about how the game determines that here the ball has touched either the border of the screen and it's game over, or has touched a segment of the circle. And what it uses the physics body. So how does it work? We've got, so this is the contact, meaning that SpriteKit has detected a collision between two bodies and is now asking us to reflect in the logic of our game that collision. So what we do is that first there is this weird thing like to give an order. So to say, okay, the first body is body A and the second body is body B. That's a bit weird, but I think it's a trick used so that you don't need to like you only compare in one way. It will become clearer when we see like the rest of it. So this code allows us to have the first body involved in the collision and the second body. And then we do if the first body is a ball, and for that we need to look at the category bit mask. What is this? It's this thing. So it's like 1 bit at position 0 for a ball, 1 bit at position 1 for a border, so a part of the circle, and 1 bit at position 2 for the scene, so like for the edge of the screen. And this is very like low level, but this is useful because it's very fast to like compare. And this is what basically allows SpriteKit to determine collisions in a very efficient way, because it needs to be computed for every frame. And back then there were 60 frames per second. Now there are 120 on iPhone 13 Pro and 14 Pro. So it needs to be performant, and this is why you have this kind of like low level code. And so this code right here allows us, because there is an order, like this is bigger than this, and this is bigger than this. If we do this code, which is just like, this is a sorting algorithm, but that only works when you have like 2 elements, it makes it so that the first body will always be the one with the lowest bit mask, and the second body the one with the largest, and it just simplifies the if statements. And so we say if the first body was a ball and the second body was a border, so a part of the circle, then we have the code to deal with the fact that a part of the circle has been destroyed. And so what we do is that we get the node associated with the second body that we know is a border node. And if there was indeed a border node, what we do is that we remove it from self. So self is a scene, so we remove this node from the scene. You can see this syntax right here, at and then square braces, allows you to create a dictionary like with a nicer syntax. But before that, you had to do like ns dictionary, ns array, sorry, ns array with object, and then as an object the border node. You need to do something like this. It was kind of tedious to create like arrays, and so they added this nice syntax to be able to create an array like using like a literal syntax like many language already supported. But this arrived also with iOS 6, so quite late in the lifetime of Objective-C. So we remove it from the nodes being displayed. We also remove it from the border nodes array that we maintain. Then we tell the game manager, so like the leaderboard, that the border has been destroyed, so that we can update the score. We also update the score with the current score, so it's the score node we saw before. and we run the action break sound that was supposed to play a sound, and unfortunately it didn't work for some reason. And finally, if after this the array of border nodes has a count equal to 0, it means the level has been completed. And other possibilities, if the first body was a ball and the second body was the edge of the scene, then it's game over because we have lost. So what's interesting is that even though this code is a bit complex, it's still quite short, and almost the entire logic of the game is implemented in this method. So that's why I was able to implement this small game in a weekend, even though oh, sorry, I'm just realizing right now that it was hiding a little bit. Okay, not too much, thankfully, but sorry about that. That's why I was able to implement this game in a weekend, because once you've understood, you've seen the tutorial, you understand how to detect the collision and how to deal with it. It's quite simple, actually. It's quite simple because the game is simple by design. All right, then we have the gesture recognizer. So how do you translate the gesture into border speed and border angle? And so what I would do is that I would get the velocity I have in the view when swiping, and to set it as the speed. And for the border angle, I would increment it. And for that, I would get where am I on the X in the view, and divide it by a gesture to speed factor. So as a way to divide the amount of pixel I would have moved, my finger would have moved, because otherwise if I move from 20 pixels, which is almost nothing, and the circle changes by its rotation by 20 degrees, it's going to be a lot. That's why there is this factor of dividing by 2000. And then I just reset the translation at 0 in the gesture. Okay, and then set up the game scene. So when I want to start everything, so scale mode, aspect fill. So I guess that's why it doesn't I guess that's why it takes all of the screen. If I do scale fit, let's see what it's gonna do. Okay, so this is iPad mode, basically. But I guess the reason is that now, oh, okay, I get it. The reason why it's displaying outside is because the ratio, the iPhones are much more taller than they were before. Like when I did this, it was in iPhone 5, iPhone 6. So that's why it doesn't feel. But right now, you see everything is being displayed correctly. The game isn't easier in... Oh, damn it. You see, I created the game and I cannot even beat it. That shows how hard it is. Okay, I'm going to set it back the way it was. So the anchor point, we anchor the scene at the center of the screen. So physics body. So physics body is really what will be used, what is the border of the node that will be used for the collisions. And so in my case, as the physics body for the scene, I say that the body is basically the border of the frame of the view. Okay, so the category bit mask is the constant I showed you before that allow to do some efficient collision testing. And you can see that I set the category bit mask for the scene, and I also set this contact test bit mask. And what this is the kind of objects that I allow my node to have contact with. This way, it avoids testing for unnecessary running code for unnecessary collisions. And so here I say that my physics body for my scene is allowed to make contact with the balls. But if for some reason, the border of the circle were to touch, actually, I say for some reason, but now that I've put aspect fill back, you can see that the border of the circle are touching the edge of the screen, but nothing happens. That's because the edge of the screen, so this physics body is not allowed to interact with anything else than the body of the ball and not the borders. So that explains it, actually. Okay, then we get it the contact delegate. So this is what we call the method that we just saw did begin contact. We give it a gravity, and here you can see that there is no gravity because everything is happening gravity less. If I were to give it a gravity, the ball would be attracted towards the direction of the vector of gravity I would have given. And then so we have the label node that is created with a font and some text, some font size. So this is basically like this is the equivalent of a UI label. Then we add it as a child node. Same thing for the score. And finally the break sound, so break sound.wave, which I had created. And to set up a game level, so there is a background color. So I guess there was a way to create like I created a factory. And I create my ball node. So I have a factory to create it also. So let's see what the factory to create a ball looks like. So yeah, it's basically like a 2D code. So we create a node, we create a path with a width. All right, that width is 25. So we set the path, we set the physics body. So it will be a circle with radius half of the width, makes sense. And for the center, we put it at the center. The physics body, so there is no friction. That means that when the body is going to touch another body, it's not going to lose any momentum. Restitution to one, I think it's kind of the same thing. It's the fact that if something touches it, it's not going to, or it's also going to like to give back all of the force. Linear damping and angular damping, I guess it's how it reduces naturally, but I'm not sure. Category bit mask, so it's what we've seen just before. So it's a ball here. Collision bit mask, so it can collision with a border. And contact test bitmap, same thing. I'm not sure about what the difference is between collision bit mask and contact test bit mask. Honestly, I'm not sure. And then there is the fill color and the stroke color. Okay. Okay, we will see the other one afterward because there is a bit more code inside of it. Okay, and finally, so to create the borders, so the chunks of the circle, so we call border nodes for level. So here there is a bit more like work because we get the level number as an integer. And then what we do is that, so I create an offset. So it's like at which interval I'm going to cut off my circle. And it's going to be 2 pi over 8 times the number of the levels. So for the level 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have like I don't see if we whether I'm not sure whether we have I'm launching the app again to see whether there is 8 or 10 segments. Okay, there are only 8 segments, which makes sense. So on the first level, there will be only 8 segments. Then there will be 16, and it's going to grow like that. And so what we do is that we create a loop to create all of the nodes, and so we create them with a start angle that will be the offset time the variable I. It will end at I plus 1 time the offset. Okay, and we say whether or not it's an odd segment because, as you can see, the color like changes between odd and even segments. So yeah, like that code, I think that probably took me like a bit of time to find the trick to make it work. But once I had found it, it was pretty easy to create my game scene, my game level. Okay. And then we have code to clear the game once the game is over. So like we remove everything. Okay. And so to launch the game, we get a random angle. Oh yes, because the ball starts at a random angle. So that's kind of nice. I had thought about like making this random to make it a bit more like interesting. So yeah, if I launch it, okay, it seems to be always launching at a random angle. Yes, a random angle. Okay, so arc for random, the method that would give like a random like integer in Objective C. Okay, I guess I scale it so that it's between 0 and 1, and then I multiply it by 2 pi. And then the ball node, the physics body, I give it an impulse, which is going to be constant time the cos and the sine of the random angle. So to be able to give it like an impulse across the y and the x direction, and I project my vector using cos and sine. I start the game and I remove the ready node, which is like the label. Okay, show game over is just like managing a transition. Oh, we have a transition to do a fade. I had done things well to transition to the game over scene. Okay, and when the level is completed, we clear the game and we start another level. All right, so that's how you implemented sprite kit in Objective-C. I don't know if it has changed a lot, but I had done a tutorial from Ray Wenderlich in 2017 or 2017, I think, about SpriteKit in Swift, and I think it was kind of similar. Like the core idea is this idea of a fixed body and of collisions. So we saw the scenes, we saw the nodes factory, we saw the colors factory. So like scene background. Oh yeah, that's something people used to do a lot, like to create like because we didn't have like enums with constants that like we can have in Swift nowadays. You would create like a type with static methods that would return like a color like this. And by default, there were no init to deal with an hexadecimal like hashtag FFFFFF, that kind of thing. So you would need to compute the amount of red, green, and blue like that. That part, when I see it, it does feel very old. Okay, but I think we've seen like oh no, let's see like the code that draws the border. So PB border node. So you create it with a start angle, end angle, and whether or not it is an odd border, an odd or even. Okay. And then, yeah, I create a UI Bezier path. So that's like center at 0, radius, border width, start angle, end angle, clockwise. So actually, it's pretty straightforward. Yes, because since we are like, we've put like the center of our coordinate space at the center, and then we use angles, and it's pretty like, it's pretty straightforward. Okay. And here we say, so the bit mask of the border is that it's a border and it can make contact with a ball. Okay, think we went over like this second project. So the game, the time I was a game developer, and we can finally move on to the last project we are going to cover. I think it was my first Swift project ever. Maybe the first time I wrote Swift, actually. So this is really like the origin story part of this live. So let's see. It's this app called Geomento. So you can no, yes, this one is called Geomento. That's weird because the one called Visual Reminder is inspired by the movie Memento, but the one called Geomento has nothing to do with the movie. Like my naming is terribly inconsistent. So let's just see like a file created at the beginning of September 2015. Ah, that's interesting. So just after I had made the little game, like I made the little game in July, and then in September, I guess like another rush of motivation, and was like, yes, I'm going to create, I'm going to create another side project. So just like before, I'm going to run it on my device. This way I can show you how it works. And since this one uses geolocation, I need to remember to override it because I don't necessarily want to show where I live during a live stream. So let's see. Okay. Okay. Let's go back. Let me show the screen of the iPhone. So you can see Geomento is here. Once again, I had made a custom app icon. I was pretty proud of myself for that. And so I'm going to start it. So once again, it's an app about taking pictures, and it's about taking notes with these pictures, but with geolocation added. So like I have progressed in my typical like side project idea of an app to take pictures and take notes. So I'm going to allow the geolocation. All right. And so I'm going to check. I need to relaunch it from Xcode if I want to override the location. Yes. So I'm going to set my location in London. All right. I'm going to take picture. So like this. So once again, I take a picture of the beautiful remote to control my lights. And I'm just going to remove the iPhone because I want to make sure that, okay, it does show London. So we are good. And so we have this added to a very like bare bones list. When you click, this time you do have a detail view and you have the picture. You cannot see it in full screen, but you have the picture. You have what looks like a post-it to be able to write some comment like this is the remote for my lights. So like that. This time when I do return, it doesn't dismiss. Oh, but when I swipe, it dismisses. That's nice. And then we have the place, because that was the key feature to be able to remember where you had taken the photo. And nowadays it's embedded into the Photos app, but back then I'm gonna say that it wasn't, or maybe it wasn't, I was just not aware of it. And so it shows where the picture has been taken, and here I'm faking my position to be in London, and so you can see I can also show it on the map. And what's great is that if I change again, this time I put myself in Tokyo, for instance, I take another picture, so my apple juice. You should be able to see that on the map, if I dezoom a lot, yes, we can see like the two pictures I have taken on the 2nd of March. So one from London, one inside in Tokyo. And when you tap, you can also navigate to the detail view. That's pretty cool. And let's see for the other one. Okay, data hasn't been persisted, so I might not have implemented things like super well, but it was my first app in Swift, you know, fun times. So let's take a look at what we have. So here we are in much more familiar territory, I guess, because so when I wrote the app, it was in Swift 2. Unfortunately, you cannot run Swift 2 on Xcode 13. So I had to convert it to Swift 4, which was not fun at all because many methods have been renamed, and basically I spent like close to 1 hour doing the renaming. But you can find in the links I've put in the description, you have the links of my project on GitHub, and you have the original Swift 2 code that you can check out if you want. So let's take a look. We have the app delegate. So the app delegate manages the core data stack like this. Okay, we have the method like save context that we saw before, something to get the document directory. So what we saw actually in Objective-C before, because it's part of the core data stack. The manage model, which this time is a lazy variable, because it was one of the big features of Swift to be able to implement lazy variables using the keyword lazy and not having to like manually do the if the underlying variable is nil, then I instantiate routine that we saw just before. So same thing for the persistent store. So it's the same like logic than what we'd seen before. And to save the context, still the same kind of things. So let's see. Let's take a look. Okay, so the launch screen, there is nothing. The main storyboard. So we have a tab bar controller because there are two tabs. The list that we just saw, so where we have the cells, and then the map. In the map, we have the map view, and we can navigate to the detail view. So this is the I feel like I'm showing you one of the example Apple shows you when they say like, look at the storyboard, it's wonderful. You can see your entire app flow in at a glance. And of course, when it's that simple, it's great. It's when it becomes more complicated that trouble starts to arise. So let's take a look. Oh yes, because we are in 2015, I have created a base view controller that does absolutely nothing. But back then, people were like, yes, it's a good practice of software engineering to create a base class for your view controllers. I don't think we do this anymore, and for good reasons. But yes, that's why you see that the code is old. So then we have like the list view controller. So list view controller, it inherits from spot view controller. Ooh, I had put some. Oh yes, I had put some code in common for the list and the maps in superclass, which is like a bad way of doing things because it becomes unmanageable so fast, basically. But okay, spot view controller inherits from the base view controller, so we have 3 levels of hierarchy for this simple app, and so it implements the picker image picker controller delegate, navigation controller delegate, CL location manager delegate to get the location of the user. Okay, so we have a list of spots. So the spots is, I guess it's how I called the thing where you take a picture. Actually, let's start by taking a look at the data model. So we have the entity spot where we have a comment, a creation date, latitude and longitude, so the coordinates, a modification date, and a photo. So once again, this transformable thing that allows us to persist a UI image super easily. a fetch request to get all of the spots. So this time I didn't create this intermediary list, which was a bit weird before and was not necessarily like needed when you have only one list in your app. All right. And so if I look at the model, so we can see the spots. So it implements manage object. It implements MK annotation. This way I can also display it directly on the map. Today I would definitely conform to MK annotation through an extension. But back then, the good practice of using extension to conform to protocols was like Apple was starting to talk about it, but it was really like only getting started to take hold. So it was not that uncommon to find like this kind of like conformance that were not done in an extension lower in the file. And yeah, you do like mark MK annotation. Of course, today you would do like you would do something like this. You would do like extension on spot MK annotation and do your thing like that. That would be much better. And so, okay, we have the coordinate, the title, and the subtitle, and this is what allows me, like when I tapped on the map, on the pin on the map, it displayed in a little like bubble the title and the things. This is what the coordinate allows to put the pin on the map, and then the title and the subtitle, they are used when you interact with the pin on the map. And so here we have the core data properties. So this is generated by core data, and everything is NS managed. So good opportunity to see that that NS managed is not a property wrapper, because we are in Swift 2 in 2015, so way 4 years before property wrappers. Yeah, 4 years. NS managed is a keyword of Swift that was added to make Swift interoperate easily with core data. So the spots view controller, so in ViewDload, what do? We fetch the persisted spot list, all right? We do the same thing in view will appear to always have fresh data. We configure the location manager, so desired accuracy of 1. I guess it's 1 meter. I don't know if like it's a kilometer. Okay. I guess it's a kilometer. Even though a kilometer seems like a little bit wide, because like if you give me a coordinate with a 1 kilometer radius from my home and I want to remember where I took a picture of something, it might not help me a lot. So I guess it's less than 1. Let's see. If I do a command click, do I get more luck? Okay, just the lower the values in meters. Okay, so it's in meters. So I said 1 meter. I set myself as a delegate, and then I have the permission if needed. All right. So it was done in ViewDload asking permission. That's why the alert popped up immediately. Okay, if there is a memory warning, could have gotten rid of it. Refresh data doesn't do anything. Oh yes, because it's an abstract method that will be implemented by the subclasses. Okay, that's why. Yeah, because there was never a proper support of abstract method, neither in Objective-C nor in Swift. That's kind of funny. And so fetch persisted spot list. So this is the equivalent of the add fetch request you would do in a Swift UI app currently, like you have to do a Swift UI app. And so persistence manager, shared instance, manage object model, fetch request template for the name. So this is the name of the query we have created right here. Okay. If you're curious as to how you can create a modern app, a modern Swift UI app that uses core data, I've done a live stream with Donny Valls at the beginning of 2021, I think, and you can check it out. He showed a really great example of a Swift UI app that used core data in a very modern way. And then we get the spot list, and you can see like, whoo, all of these exclamation marks, because so it's not only because I'm just discovering Swift when I'm writing this code, but it's also because back then, like in Objective-C, we've seen that a lot of things were pointers, and pointers can be nil. So a lot of things were optionals. and basically you had to force unwrap because otherwise you are always dealing with like optionals, but with no like but with no clear error path other than crashing. So that's why there was a lot of like force unwrapping back then, which always felt a bit weird, like adding all of these like exclamation points. It feels a bit like you are like you're yelling at your code. But yeah, that's I think that's typical of apps that were written in Swift 2.0 because it changed a lot in 3.0, but in 2.0 it was already the case a lot, and it was even worse in 1.0. Okay. So yeah, one of the things that I had to change is that in Swift 2.0, like for constants and for cases of an enum, they would start with a capital letter, and it was changed to camel case afterwards. So I had to like rename all of the existing like constants you can find in the colon GitHub. Like you still have the old syntax, but okay. When we add a new spot, so that's to when the button is tapped, we present a UI image picker controller in the delegate, so we get the captured image, we resize it. So I guess I reused my Objective-C code from the previous project and converted it. Then we create like the new spot. So we do this thing like NS entity description, so as a way to create a new managed object into the managed object context. So with this nice like forecast, because this returns like something that is untyped, it returns, I guess, it returns an NS managed object, but you need to downcast it to the right class. So not very type safe at all. Okay, and then we set the photo to it. We set the location if we have one, creation date, modification date to be now, and we insert it at the beginning of the spot list. And then we dismiss the view and we save the managed context and we refresh the data. All right. And this is to deal with the fact that once we are authorized to use the location, we start monitoring it. So that's the base class that is used both by the list and the map view. And so the list, what it does, so it creates, it defines a cell identifier. So view does nothing. View will appear, refreshes the data. So we have the prepare for transition to the detail view. So we just like create like, if it's the segue to transition to detail view, we get the destination, which is detail spot controller, and we set the selected spot. So what you would do with like a navigation link in SwiftUI. Okay. And refresh data, we implement it because it's an abstract method. I mean, a makeshift abstract method. And so when we want to refresh data, we fetch the persisted spot list. Then we sort it by creation date. That makes you wonder why I created a modification date if we don't use it for the sort. And then we reload the section. Okay. Yeah, what's crazy that here you see, for instance, I'm doing, I think, honestly, when I wrote this code, I do not know how, back when I wrote this code, I don't know how optionals work because there is absolutely no point in doing this. Like you can always do this. I mean, like you don't want to. There is no reason to crash if spot list doesn't hold a value because you're not using its return value anyway. And of course, it's still like it's still built. So like yeah, when you see that, you really see the fact that I'm very junior in Swift when I'm writing this code. Here I'm force unwrapping, but it's not the same thing because like this is coming from core data. I don't control it, and so like it makes a bit more sense. But here like when I see it, I'm like, what was I doing back then? So the method that conforms to at Objective-C that allows us to have a selector that can be called by the button, okay? And then table view, so number of rows in section, so the count of the list, cell for row at index path, so we dequeue, we get the spot according to the row of the index path, and we set the cell. So you can see that I used only like the default, the IB outlets available by default on a cell, so text, detail text, image. I didn't want to spend too much time writing a custom cell, I guess. Okay, if I select one, I immediately like deselect it because it will also automatically like trigger the navigation because I set that in the storyboard with the segue. And finally, the commit editing style, so to be able to get the swipe to delete behavior. And basically, it's kind of the same code than what I've showed you before in Objective-C. I think I got inspired a lot from the previous code, honestly. And in the map, it's kind of the same thing in the map. So we have a map view instead of a table view. We have a reuse identifier because there is the same logic of reuse identifiers for the pins on the map. And so when view did load, we add the annotations on the map and we show the annotation. So there is a little bit less. Yes, no, yeah, there is still a little bit of the annotation view logic of dequeuing, but there is this thing where you say like, I want to add this annotation and I want to show them, whereas with the table view, the data source asks you like how many items do you want to show. Here it's a bit different. Okay, in view will appear, we refresh the data. So we have the prepare for storyboard when we navigate towards the detail view also. Refresh data, so we just like so we get the displayed annotations, we get all the annotations. Oh, we turn them into sets, so that we can compute the difference between what is all the annotation and the one that are already displayed, and we can only add the one that are needed. It's kind of nice. To be honest, maybe that just like removing everything and adding everything back again would have done the same thing. But kudos to myself for using sets back then. And honestly, I think I just wanted an excuse to use sets back then to just try it out, because it doesn't seem like to be like super useful to work that way. So same thing like add button, okay. And so map view did add, so when there is an array of new pins added to the view, we iterate over them, and for each of them, like, we create an image view that we put. Okay, so this is where we can like customize the MK annotation view, which are like the little pins we saw. And so on the left, we put a small image, so the image resized to 40 by 40. And on the right, we put the detail disclosure, so the little like eye, circle eye button that we can type to navigate to the detail view. Okay. And when that right callout has been tapped, we perform the segue to navigate to the detail. And you can see like I do it by saying, okay, if it's a UI button, this way, like if you type on the image, it doesn't navigate. That's a bit of a trick. Honestly, that doesn't like scale a lot. Also, like I could have used like is instead, but maybe like something like that. Yeah, but maybe is wasn't available like back then, but or just I didn't know about it. It's so nice to see this code. And then the detail view, like with the table view. So let me show you the detail view a bit again, because like so it looked like this. So a table view with like 3 sections. And table views, they were kind of annoying to do them back then. I'm curious, if I look in the code, I'm curious to see whether I used a static table view or not. So let's see. Not the launch screen. Yes, I had used a static table view. You see, I can scroll inside the table view. This way, it limited the amount of code I had to write, because honestly, like I think I wrote this like like 2 or 3 evenings, but I didn't want to spend too much time on it. It was just like for fun to discover Swift. I think it's because like I had been told I would be starting my first like mission, because I was in a consultant agency as an iOS developer, and I wanted to like be like well up to date, because I hadn't been doing iOS for a couple years back then professionally. So that's why I had written this app, I think. Okay, and in the detail view, what do we do in the detail view? So view did load, we set the image view, the text view, the map view. Okay, yeah, because even though like the trick is that there is a trick here. Trick is that even though it's a table view, since it's static, the table view is only managed in the storyboard, and then you see like this image view, there is only one, and I have hooked it up to a property image view in the code. Same thing for this text view right here, and same thing for this map view right here. And this was like really what allowed me to implement this app without spending a crazy amount of time on it, because otherwise, if I had needed to like create cells, configure them, etc., it would have been like boilerplate and annoying, and that was a shortcut to make it kind of work while still being simple to integrate. And what's funny is that this is kind of similar to what we would get nowadays on SwiftUI by using like a static list. So I would set everything in view did load. In view will disappear. I would save the eventual changes, even though we saw they were not always changed. Oh no, because it was they weren't changed. Okay, when there is a memory warning, I do nothing. And so if the map is tapped, it's supposed to do something. Okay, I tried to tap the map and it crashed, saying unrecognized selector map clips sent to instance. Okay, so I guess I wasn't supposed to tap the map. Let's see, I'm going to try and fix it. Oh, I think it's because of that. Okay, let's see. I'm going to show the phone again. I'm going to tap on the map. Okay, now it opened it in map, yes. So it's one of the super annoying thing when I had to like convert like the project. You see there is the same issue here. That's why the changes were not saved, is because in the big renaming, like they added this underscore in the signature of the method, and so this method wasn't called, and that's why the data wasn't saved. Okay, so let's see. I'm relaunching the app. I'm going here. So like I'm going to say like, this is my apple juice. Like that. So like that. I go back. Okay, now it's been saved. All right, so it's not that I had done like a bad job at implementing the app. I had tested it, it worked, but it's when I converted the code from Swift 2 to Swift 4 that I made this mistake right here. Okay, I'm kind of glad to see that I did a good job when I implemented this app. Okay, and so yes, it would create like a map item and then just open the maps app so that we can see like the place where the photo was taken inside the maps app. And I think we've covered everything because it was a nice little simple app, kind of like a CRUD, basically a CRUD app. Very simple to get started, to get familiar with Swift, without spending a bit more than 2 or 3 like evenings on it. I'm super glad because I see it's almost 10 p.m. in France, so 2 hours of live, and I didn't want to go over like 2 hours because afterward, like if I spend too much time on the live stream afterward, like it's a bit hard to get to sleep, and I would like to get some sleep this night. So I'm glad that I've managed to cover everything I wanted in the 2-hour time frame. I hope you've also enjoyed this live. It was super nice to go back to my old Objective-C code, my old Swift code, see that I used to do things like putting a donate button in ridiculously simple apps. That was really fun. So now you can have an idea of what I was doing, what kind of content I was creating before I started to do YouTube. I was making these weird apps and posting them on GitHub and hoping that adding them to my resume would help me get better job opportunities, because that's basically like that's basically the reason of being of these side projects. Yeah, like I was saying, I had a ton of fun of making like that live stream. I hope you've enjoyed it. I guess I just have to say thanks a lot for watching it. Have a good rest of your evening, of your day. And see you next time. Bye bye.